Let's solve Leetcode problem number 49, group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. For those of you who don't know, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. For example, act and cat are anagrams because I can take the letters A, C, and T to form the word cat. As a result, given this array of strings, we expect to see the following two-dimensional array output, where each array in the returned array is a collection of anagrams. The intuition for this problem comes from the following question. If I have a string, like eat, how can I find an anagram of this string from the input? Well, what if I sorted each string alphabetically first before making the comparison? This makes it really easy to determine if a string is an anagram of another string, since we can sort both strings and compare their values. If they aren't equal, they aren't anagrams of each other. However, if they are equal, they are anagrams of each other. This raises the next question. When I've sorted a string, how can I group other similar sorted strings? This is where a hash map comes in handy. For each string, we sort the characters and look in a hash map. If it doesn't exist in our map, we insert it as a key where its value is a list of elements, the first of which is the string itself. If the string is already in the hash map, we can simply append the value to the list of values for that key. Once this is all said and done, we can simply return the values from the hash map as our final answer. Although this isn't a terrible solution, having to sort each string before making a comparison eats up a large portion of our time complexity. Assuming n is the size of our input array and L is the length of the largest string in our input, this approach would give us a time complexity of big O of n times L times log of L, since we would have to sort each string before placing it in the right place. We can assume that comparing the sorted string to keys in the map is a constant time operation, and that inserting an element to an array is also an amortized constant operation. The space complexity here would be big O of n times L, since we would be creating a hash map consisting of all the characters from the input strings. Can we improve our time complexity here? Asked more directly, can we use the fact that the input strings only consist of lowercase English letters to our advantage to drop the burden of sorting from our time complexity? It turns out we can. Since the input strings can only consist of lowercase English letters, we're only ever dealing with 26 letters at a time. Not only do anagrams have identical sorted forms, but they also have identical character counts. What if instead of sorting the values before storing and comparing them in our hash map, we instead created a new array which has a length of 26 where each index represents the count of characters present in the string at that index? For example, for a string like cat, we would have an array like this, and for eat, we would have an array like this. These can be created for each string in big O of L time instead of big O of L times log L time, which significantly drops our time complexity from big O of n times L times log L time to just big O of n times L time. The space complexity would not change. Note that before storing these array values in our hash map, we have to convert them to a tuple first, because we can't store non-immutable values as keys in our hash map. Tuples by definition are immutable, therefore they can exist as keys in our hash map. This is how the final solution would look as a result. Thanks for watching, and see you in the next one.